Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Amirul Haziq bin Nawawi. My number matric is AA191153. Now I will explain about the problem statement 1, which is required us to make a single acting cylinder will extend when the push button is pressed. A lamp will on when the cylinder has fully extended, detected by the limit switch. After 4 seconds, the piston will retract to its position and lamp will switch off. So what I have done in this circuit is I'm putting the cylinder acting single acting cylinder with 200 stroke maximum stroke, 3 two-way valve, and uh, a service unit. So for this explanation, when I push the push button 1, R1 will energize. When R1 is energized, contact relay here will be a close from normally open, and 1B1 will become close from normally open also. So then this circuit will be on. So the relay, so the timer that I already set to 4 seconds will turn on. So this is how it works. When I push the push button 1, R1 is energized, and then this will make the lamp will turn on. So after 4 seconds they are already set, the circuit will become open. So the lamp will not turn on anymore, and the circuit become like normal without the lamp turning on. So I run the simulation. When I push the push button 1, R1 energized, so the lamp is on. After 4 seconds, the lamp will turn off, and the cylinder move to its initial position. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Erin Eriana binti Syafzainizam. Matrix number AA190939. So today I'm going to present about problem statement 2. So as you can see, here's my problem statement 2. There are two vertical rail, which is one is input and another one is output. The input is 24 volt while the output is 0 volt. There are 10 rungs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first, let me run my simulation. Okay, when we press the start button, the circuit of the conveyor belt will energize until the bottle will stop at the filling station. So, when the sensor sends the bottle, the conveyor will stop and the water valve will open for 2 seconds for filling the liquid into the bottle. So then the yellow indicator also will be signal when the water valve is open. So after 2 seconds, the conveyor will move again until the bottle is sensed by the sensor 2. Then conveyor A will stop again, and a solenoid is energized for 3 seconds for a piston to push the bottle into conveyor belt B. This time, the red indicator will be signal when the water valve is open. So, then the process is repeated Lastly, the process is repeated for another bottle until the reset or stop switch button is pressed, which is this one. Okay, so that's all from me. Thank you.
This is the pneumatic circuit of 3-cylinder system, and this one is the ladder diagram of 3-cylinder system. Meanwhile, this is the table for the parts list, which is the component that we use in this system. In the pneumatic circuit, we have two different parts. The first part is the cylinder part, which is the actuators or working element, and another one is the valve part, which is the signal input element. Right here, we have three pieces of single acting cylinders named as cylinder A, Y1, cylinder B, Y2, and cylinder C, Y3. Also, three pieces of three two-way solenoid valve named as solenoid valve A, solenoid valve B, and solenoid valve C. And at the bottom here, we have three pieces of compressed air supply, also named as air supply A, air supply B, and air supply C. In the ladder diagram, we have two different parts, which is on the left, we put all kinds of input, while on the right, we place all types of the outputs. So there are several input that we use in this ladder diagram, such as start push button, named as PB, emergency button, named as EB, three pieces of limit switch sensors, named as S1 for sensor A, S2 for sensor B, and S3 for sensor C. Two pieces of normally open contact, named as R1, and two pieces of normally open relay contact, named as R2 and R3. For the output, we use relay coil, named as R1, two pieces of on delay timer, named as R2, that we set to 3 seconds, and R3 that we set to 4 seconds, and three pieces of valve solenoid, named as Y1 for cylinder A, Y2 for cylinder B, and Y3 for cylinder C. The process sequence of this system was like this. The initial position of cylinder A, Y1, and cylinder C, Y3 is retracted, while cylinder B, Y2 is extended during they are not energized. When start button PB is pressed, current supply will flow through the circuit and energize the relay coil R1. The normally open contact R1 will close and make the cylinder B Y2 to retract. When sensor B S2 detects full retraction for cylinder B Y2, the current will flow through the on delay timer R2 and make it turn on. After 3 seconds, the normally open relay contact R2 is closed and causing the cylinder A Y1 extends. When sensor A S1 detects maximum extensions for cylinder A Y1, the normally open limit switch of sensor A S1 close and allow the current flow through the on delay timer R3 and turn it on. After 4 seconds, the normally open relay contact R3 close and make the cylinder C Y3 extends. All the system reset or off when sensor C S3 detect maximum extensions for cylinder C Y3. The system also will be reset or off when the emergency button EB is pressed at any time during the operation. So the simulation of this system is like this. Press the push button PB and the current will flow and affect both the 3 cylinders. And if we want to reset the system during the operation, just simply press EB, which is the emergency button, and the system will be reset or off.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shalin binti Amir Saifudin and my number matric is AA191472. I am from section 1. Today, I would like to present problem statement 4, which shows the PLC CPM2A used to start and stop the motors of a segmented conveyor belt. Based on this problem statement, 3 proximity sensors should be included that is needed to users for each conveyor segment. This is a ladder diagram and electropneumatic circuit that shows how the motors and sensors operate when they detect objects. When the start button is pressed, the 24 volt of the voltage supply applied in this electropneumatic circuit. The current flows through the DC motor M3 and it's starting the operation. Then the relay coil motor 3 will begin to energize. When it's fully energized, motor contact 3 will be closed. The valve solenoid relay Z3 will respond to the solenoid Z3 at the 3 halfway solenoid valve. Hence, the valve will automatically push to the right. So, motor 3 will turn on. Motor 3 will always on unless the button stop is pressed. When sensor 3 has detected the object, the S3 contact will be closed and the current flow to the DC motor M2. The DC motor M2 will turn on and start operating. Then, the valve solenoid relay Z2 starting to energize. When it's fully energized, the valve solenoid relay Z2 will respond to the solenoid coil Z2 at the 3 halfway solenoid valve. So, the valve will automatically push to the right and start to operate. When sensor 2 has detected the object, the S2 contact and S1 contact will close current flow to the DC motor M1. Then the bulk solenoid relay coil Z1 will start energized. When fully energized, it will respond to the solenoid coil Z1. So motor 1 starts to run by assuming the solenoid Z1 activates to operate when it pushes to the right. When sensor 1 has detected the object, the S1 contact is already closed because the motor 1 has turned on. So motor 1 starts to run by assuming the solenoid Z1 activates to operate when it pushes to the right. At the same time, the current flow through the relay will switch on coil motor 2 and start counting for 2 seconds. After 2 seconds, the contact motor 2 will be closed and the current flow to the bulk solenoid Z2A. So the motor 2 will turn off by assuming when the valve solenoid Z2A responds to the solenoid coil Z2A and push it to the left. As sensor 1 has detected the object, the relay will switch on coil motor 1 will start counting for 4 seconds. After 4 seconds, the motor 1 contact will be closed and current flow to the valve solenoid Z1A. So motor 1 will turn off by assuming when the valve solenoid Z1A responds to the solenoid coil Z1A and push it to the left. This circuit will operate until the start button is pressed to stop the current flow through the circuit. Okay, that's all from me. Thank you.